Great, let's kick off here. Good morning, everyone. My name's Stephenson from Corero Network Security. I'm going to be speaking this morning about DDoS considerations for mobile carriers, and I've oriented the talk and the observations towards things I think would be useful to the membership, CCA attendees. We do have a few CCA members as customers, so we have some experience directly with this class of carrier, and won't be sharing any of their details by name, but happy to chat afterwards on our booth or during the rest of the show. I'm a CEO, a tech CEO of a DDoS company called Corero Network Security, and in my travels I'm fortunate enough to meet with a lot of providers, hosters, wireless ISPs, building ISPs, people who are providing connectivity to the internet for their customers, customers. Sometimes they're dealing with a single customer, a very large enterprise, maybe a global enterprise. Other times they might have hundreds of thousands or even millions of hosted customers in their networks around the world. And what I've done for us in today's discussion is rolled up some of those learnings and observations and considerations, and tried to provide insights, hopefully useful insights for you on what might be applicable to your business or your technology, depending on how you play in the mobile broadband space. We're based in the US and UK. I'm from the UK, but I'm based in Boston, Mass. I've been there for 30 years now, but we also have a development research facility in Edinburgh, UK. And then we sell our products all over the world. So over the last 5 years, we've been shipping what we call our SmartWall product to communication service providers, mobile SPs, cloud hosting, data centers, digital enterprises, pretty much anybody who has a task to connect to the internet in a secure, available, reliable way, and have recognized the need to provide DDoS protection for that access. Sometimes they're local, regional, many times they're global. Their deployment capacities range from a few tens of gigabits of transit peering up to terabits. And more recently, we're into 10 terabit space as well. And I'll talk a little bit about how we're handling that challenge. And the way they deploy our technology, it might be a handful of sites in some cases, 2 sites, 4 or 5 sites, 10 sites, but more recently we've been expanding to customers who have hundreds of sites around the world, taking them into this multi-terabit space. We monitor many of our customers. We offer a managed service along with our DDoS protection that allows them to securely share attack data with Corero. We have a security team on hand 7 by 24 by 365 to assist them. Because many times, and I think this is the case with some of the CCA community, they're not large enough to have their own security teams or SOC round the clock, and they need either supplementary or outsourced capability to protect their own infrastructure and their customers' infrastructure. That means we're one of the biggest users of our own product, and by that I'm referring to the analytics that we built into the system. It's been the way we've improved our technology and learned so much about DDoS, and I'll share some of the learnings in the next few slides. But we continually monitor a large number of our customers to help them protect their networks. That gives us access to hundreds of thousands of DDoS attacks a year. We get to see how our technology, software and hardware, analyzes, detects and blocks those attacks, while at the same time understanding what we might need to do in the future as the DDoS attacks evolve to continue to protect those customers. That also gives us a very rich set of data that we can analyze, using modern techniques, machine learning, etc., to understand how those different attacks are impacting different kinds of networks, hosting networks versus landline networks, wireless networks, etc. And we try to build that back into both the monitoring that we provide for our customers, because they have access to these same tools, as well as the configuration recommendations or upgrade paths, capacity planning, etc. We do that in a variety of ways, but the fundamental framework inside our product is based on a technology called Splunk. It's fully embedded, it's an OEM technology, so you don't have to buy a license for it. It comes ready to use out of the box. But that's also allowed us to be very open and connect with many of our customers' existing systems, or allow them to come up with their own customizations to suit their particular business or needs. And obviously we're firm believers in efficiency and productivity, and have a great affinity for DevOps, SecOps kind of integrations with these products. So if we use that knowledge that we've gained over the last series of years on what's happening in DDoS on all of these monitored systems, we can summarize what we've seen in the last 12 months on a slide like this. We've seen some record-breaking high bandwidth attacks hitting the media headlines. About a year ago, Memcached was an exploit that was leveraged around the world to launch an attack on the GitHub site. It recorded over a terabit of traffic, 1.3 terabits or something. It was a headline suggesting it was the largest attack ever recorded. There's always a bit of competition between east and west, north and south on those numbers, or where the attack was observed, etc. But needless to say, it was a very large attack, and it received a lot of attention and helped people realize what could happen if we have millions of devices like IoTs or high power mobile handsets or other intelligent systems connected to high bandwidth networks, how they could be maliciously harnessed to cause damage or cause outages. I'll share some data about how many attacks were occurring during the same few hour period that GitHub happened to be become the poster child for that attack. They weren't alone, and they weren't most likely the largest attack victim during that day. We've also seen continued growth in botnets, the ability to take over or harness these intelligent resources that were proliferating for good reason across the network, both in the static, installed in homes, accessed over Wi-Fi, or accessed over mobile networks. Those bots often in communities, hundreds of thousands of the same bot occur. But often that's because they're actually based on either the same device or the same floor. And there's an important point to highlight there. It's that the proliferation of similar devices actually really motivates the hackers to break that device or figure out how to control that device, because once they've broken one of them, if there are 500,000 devices just like that one out there, they can then multiply the benefit of that hacking work to all of the rest of that community. So there's been a big incentive for hacking devices that occur in large numbers when they have the same operating system stack, networking stack, or even the same hardware and processor makeup. So we'll continue to see that as we see the proliferation of mass-produced devices, whether they be in mobile, fixed, or IoT sensors, or autonomous vehicles, whatever the intelligent edge becomes. There is a huge motivation. We're pointing out there's a huge motivation for those devices to be compromised so they can be leveraged for malicious reasons. We've also seen in the last 12 months an increase in the use of multi-vector attacks. We calculated it something like 29% I think is what we reported in our trends report. An increasing use of multi-vector attacks, which means somebody's not just attacking you with one weapon, they're attacking with multiple DDoS attack weapons at once, multiple vectors, and cycling through them, and there are implications of that for protecting your mobile carrier network as well. They've also adopted techniques that seem to be more directed towards mobile networks, with spray attacks or spectrum attacks, where they'll find out the target subnets or target address spaces and spray the attacks over all the victims, meaning the only place those attacks amass into the perfect wave or the perfect storm is in your network. So they might be coming in at low rates over many victim IPs, but then obviously when you aggregate them in your network, they accumulate into a very large bandwidth or packet per second storm. And then the last point to note here is the continued availability of booter or stressor services, dark web, sophisticated tools made easy to use for low dollars. So you don't actually need to be battling a nation state to be the victim of a large or frequent attack these days. People can access that technology themselves quite easily. So you're probably familiar, if you've been operating a network and you've been hit with DDoS attacks, you're probably familiar with their impact. It varies depending on your business or your role in the value chain, but it can be anything, the downtime or impacted service levels, lost revenue, loss of control of your own infrastructure, you don't know what's going on. It could be the operational costs you have to expend to fix problems or recover from attacks. It's the impact on your customers, making them either harder to retain, renew, or attract new customers. Just the brand and reputation that you've worked hard to build can be impacted too. And increasingly we're seeing around the globe regulatory action, fines, even legal action, and in some cases, CEOs have to resign or significant executives have to resign in companies that were negligent in protecting their network. So let's switch to a bit more of the actual analytics of DDoS and show you something related to that large attack that was reported a year ago. So the GitHub attack was February last year, middle of the day Eastern time, and clocked in, recorded at about 1.3 terabits. And Corero was up and running at that time. Our analytics were running on all of our monitored systems, helping our customers stay protected. And what we observed that's interesting is during that 3-hour period when GitHub was the victim in the center there, we saw that same weapon, that same giant army of Memcached servers in the world being pointed at hundreds of different victims around the world, sometimes with larger impact than on GitHub. We saw Alibaba get hit. We saw other big name brands get hit around the world. Every one of those little colored bars represents a 5 minutes worth of attack. And you can see there are 10 to 15 minute attacks as that sort of giant cannon was being fired around the world by the operator, the malicious operators attacking victim networks. So you'll see the actual GitHub attack pop up in a second in that circle. So that was the one that hit the headlines and got all of the coverage in the news. But there were many other people who were hit hard during that day and either kept quiet about it or they had adequate DDoS defenses, so they didn't become such a public poster child of the impact of DDoS. This has continued. Now, Memcached, that particular vector, has been cleaned up a lot. A lot of people have taken their Memcached servers correctly off of the internet. They were never intended to be exposed to the raw internet. They were for internal use only, and it was mostly configuration errors, security configuration errors, that let them be leveraged around the world. So we've cleaned up a lot of them, but there are still tens of thousands of these servers out there that aren't administered correctly and get rolled into multi-vector attacks, not single Memcached attacks anymore, not just one giant cannon focused on the victims, but combinations of vectors. Now, remember, most of those attacks were like 10 to 15 minutes. That brings us to an important consideration for operators when they're choosing their method of DDoS protection. 10 minutes, you can't rely on a human in the decision chain to mitigate or redirect traffic, especially when these attacks occur any time of day, weekends, holidays, etc. You have to automate. You have to choose a solution and optimize it for your application so that it can handle most of the work in an automated fashion. And if it can do that 99.9% of the time, which in our experience is possible, then the 0.1% of the time it might need an intelligent security analyst. Maybe you can rely on the service, the SOC of your technology provider for that, and then only in even rarer case would you actually have to be involved yourself. What you can't do is have a system that takes minutes. Sometimes it's 10 to 15 minutes with a lot of the traditional approaches to detect, redirect, and then start to mitigate the attack. GitHub, in fact, went down for the first 10 to 15 minutes before they swung their traffic over to Akamai to help them deal with it. What we've been focusing on with our customers and has been popular with modern carriers is real-time detection and mitigation. So we're talking seconds, sometimes even sub-second. So the ability to detect and mitigate accurately, 99.9%, whatever the actual percentage is, most of the time effectively, is very important. That keeps that traffic off your network, keeps your customers happy, keeps your infrastructure outside of the load curve that would allow DDoS to impact it. Now, if we also look at our analytics and take you through what we saw in the last 12 months in terms of the sizes of the attacks, how many of the attacks there were, and what the nature of them is, we reported in our recent trends report, which is available on our site, that the attacks over 10 gigabits per second in the systems and networks we monitored doubled last year. So we're seeing this onward increase of higher bandwidth attacks. We also observed that 81% of the attacks were less than 10 minutes. So fast acting, fast and furious, we call them sometimes, attack vectors are being used against victims. If we look at the chart here, what I've done on that chart is overlaid on the actual data. It's a logarithmic chart, and you'll see the vast majority of the attacks were clocked at 1 gigabit or less. And a lot of networks, a lot of servers will sort of ride through that kind of attack with only maybe a small impact on their service level. But then when you get into the 1 gig to 10 gig range of attacks, there you're seeing things that usually cause, if they're directed at a server or a service or an individual or a downstream connection, a wireless or constrained landline, wireline connection, then they'll cause noticeable damage. And then above that we get into the 10 to 100 gigabit range of attacks. These, if they were not protected at the edge, would often take customer resources down or create problems that if you don't have a DDoS detection system, you might be chasing for a while to figure out what's actually going on your network. And statistically, this is only approximate, but for this data set over 12 months and all of the customers that were monitored, people on average, and obviously averages don't always apply to you as an individual, but on average they were seeing about one of those attacks a day, an attack of this size on the average customer once a week, in this range up to 25 attacks a year, and then at the higher range above 50 gigs, on average we're seeing one attack a year. And fortunately, in that terabit space, the GitHub size attack that we were talking about earlier, as an individual customer, it's probably like once in 25 years you'll be the victim of that attack. And probably what you're going to do if you get hit with something like that is just pull the ripcord, because you can't afford to pay for protection for 25 years just in case you get hit once. Now what you have to remember is you have to fold this back. If you're a carrier who's handling 1,000 customers or 10,000 customers, of which many are likely to be victims because of what they do with their IP addresses on the internet, you have to multiply these rates accordingly for your networks. The majority of operators I've worked with in your space, and I'm just generalizing here, so apologies if it doesn't apply to you directly, but they want to protect their everyday networks and their everyday customers from the collateral damage of DDoS. They're not focused on protecting a specific customer all of the time. It's just not cost effective to take a subscriber who pays $50 a month or $100 a month and spend $10,000 protecting that subscriber. But what you do need to make sure is if that subscriber is attacked, you don't take down 100 or 1,000 of your other customers for the duration of the DDoS attacks on that one particular victim. So I'm generalizing there, but that's what I found in that community of users. So let's draw a few pictures of what's happening, and then that'll help introduce some of the ideas that we think are valuable for this audience in dealing with these problems. So the classic DDoS attack, it's been around for years, is where the good traffic is coming in from the internet at large through your intermediate, carrier network, whatever you are, a tier 2, tier 3, a wireless ISP, a regional ISP, a broadband provider, whatever. They'll come in like that, and when for some reason one of those public IPs that belongs to your subscriber base, or that you NAT or map your subscribers to, it could be the kid on Xbox, or a local site that's for some reason is ideologically a target of X's. The DDoS will come in and obviously the attackers attempting congest or put offline the victim IP over whichever network they're hosted on your subscriber side, and as a result you get congestion both at the victim but also back in your network, potentially impacting other customers. Over the last 2 or 3 years, increasingly we've seen the reverse, which is the inside-out attack, which is where your subscribers are talking to the internet and somehow they're compromised or leveraged as part of a botnet attack, either through the equipment being compromised that they're using, everything from set-top boxes to modems to MiFis, whatever it is that the attacker was motivated to figure out how to control, or the application that they're running, and that attack surface increases if they're tethering rather than just using mobile apps. The inrush of traffic can also bring down networks too, and this has happened in some of the largest broadband providers in the US and Europe. They've had hundreds of thousands of intelligent devices leveraged to attack from the inside out and take out their infrastructure, causing a lot of collateral damage. And that applies to IoT and 5G more specifically as well, or more generally. The traditional defense in larger networks has been to detect, redirect, and then mitigate, or scrub, as it was often referred to in scrubbing centers. This has challenges in that, especially as the attacks are growing, it has challenges in that you're required to backhaul the DDoS traffic to a scrubbing center across your network. So you let it into your network, then you backhaul it to the scrubbing center, and there in the scrubbing center you clean it and then re-inject it, often through tunneling, to prevent routing loops onto the destination. This typically takes time, minutes, sometimes 10 minutes, rather than the seconds that you're looking for. It also has become more problematic because of the risk in deciding when it's safe to redirect it to the scrubbing center. And I'll try and explain that in the next slide or two, but it relates to the increasing volatility of attack bandwidth as a result of multi-vector. So when people are using that traditional method, they often have fractional coverage. Their scrubbing center might be 1/10 of their transit capacity. It's too expensive to build a scrubbing center for everything, or it was in the past. So they have, I'll just use 100 gig as an example for easy math. They have 100 gig of transit and 10 gig of scrubbing, and they can nicely handle attacks under 10 gigs. But if the attack is over 10 gigs, they have a problem. If it's 5 gigs 1 minute when they redirect it to the scrubbing, and then it jumps to 15 gigs because it's a multi-vector attack, the scrubbing center is then congested, it will overload, and any good traffic going to the scrubbing center can get dropped as collateral damage because of the packet loss and crowding. So there's this very challenging betting game of what you allow to be redirected to your fractional scrubbing center in order to protect the edge of your network. What we've learned over the recent years is that if you wanted to try and build an even better, faster DDoS defense, you would think of things listed on this chart, and this is what's been driving our development in recent years. You want to look at the header of the packets, which is what, say, a traditional net flow monitoring solution would do, but in addition you want to look inside the payload. You want to start doing some deep packet inspection, sample DPI of the incoming traffic, so that you can more accurately identify the malicious attacks and figure out what to do with it when you've identified it. This is what helps you get this seconds response time with high accuracy of detection and mitigation. So you don't want to go down for minutes while you're figuring out what to do or waiting for an operator to respond. You want to automatically identify the problem accurately by also using the payload information, and then surgically mitigate the bad packets. That allows you to approach this negligible false positives. Then you can leave the system on all the time in automatic, and you'll only be dealing with the very rare case of attacks that for some reason couldn't be detected by your automatic system. You also want to log and analyze everything that's happening on your network, so you need a product that will do that for you, so that you can drive your own analysis, even in more recent times feed it into any machine learning or AI capable solutions that you have. So you want to accurately allow the good traffic and accurately block the good traffic, and rapidly, if you need to, be able to black hole that $50 a month subscriber who is putting your whole network or your whole operation at risk by dragging, a significant amount of DDoS traffic to your network. So what happens with many of our customers is they choose inline mitigation at the edge. So they're choosing to put in 100% protection on their link. So whenever they get a link, they put the protection in. And that way they get this header and payload inspection, real-time detection and real-time mitigation at the edge of their networks. And that's deployed and operating in a lot of networks around the world. We had to change the economic equation to make it cost effective. We also had to change the complexity equation to make it accessible to smaller operators. They can't afford to have a staff of 10 people around the clock just watching dashboards and dials to mitigate DDoS attacks. They want to plug it in and not forget it, but know that it's being effective in blocking the vast majority of the DDoS to their network. And that ends up looking like this. This is one of our solutions deployed to customer with, this actually is 8 10 gig ports in one rack unit, protecting 8 10 gig transit links with this kind of automatic accurate detection and mitigation solution. That's obviously for a class of customer that's in the 10 to 100 gigabit kind of space, but it's very cost effective. It's very easy. It installs transparently in that it doesn't have an IP address or MAC address. It's sort of like a smart fiber, so you don't have to change your IP routing, you don't have to change your BGP. It's very simple, very plug and play for the mid-tier of operators who want this kind of protection. Then what happens is you go back to our chart of the blue line showing the number and size of attacks. Then you're protected up to the capacity of your edge. So for any attacks that fall under your aggregate transit capacity, you enjoy automatic, accurate, real-time protection with analytics without those congestion and overload issues of making a bet of whether it's okay to send it to the fractional scrubber. And this comes in, not only I showed you n times 10 gig on the previous slide, it also comes in n by 100 gig as well. We have customers who are deploying this on multiple 100 gig links to get up into the hundreds of gigabits and even terabit space. But wait, there's more in terms of the scalability. So if we've talked about tens, multiple tens, hundreds, multiple hundreds, we now have customers who are into terabits of space. They have so many links, 100 gig links coming in their edge or in aggregate around all of their locations where they're providing service, that it's a rapid race for them to figure out how to protect their edge. Fortunately, there's another trend that's happening in the market that would be to your advantage, and that is silicon filtering in the routers and edge devices. So they're getting smarter. Actually, smarter is not the right word. They're getting more powerful in that they have this power to inspect in silicon the packet and the payload, and you already have this capability in Juniper Networks MX routing family. There have been announcements from Arista, announcements from Nokia, and also Cisco's expected to do something as well. So they have the power there to apply filters at high speed to every packet coming in the network. They still need a brain to tell them what to do, to detect the attack, figure out what is the vector, and then define the filter. But in real time, you can load these filters. And how that works in our partnership with Juniper is the Juniper Corero partnerships allows us to monitor with sample DPI the edge traffic on a network. So we're looking at the header and the payload, so we're going beyond what NetFlow provides. And then when an attack comes in, we can automatically push the silicon filtering commands back to the edge router. So you don't have to buy appliances now to do the mitigation. You're leveraging the hardware you've already purchased that's available in your Juniper router. And as I say, that same technology will be coming to other vendors' edge equipment too. It's very promising, and it scales to the edge capacity. We have 10 terabit kind of customers in this space, and using the router hardware that they've already purchased, but adding the intelligence of DDoS detection and mitigation software from Corero to turn it on or enable that power. The same thing works symmetrical, so it can work on the inside-out problems too. So you can monitor your subscriber edge, your broadband gateways or your wireless gateways So this is something that isn't limited to only looking at traffic from the internet. We now have capability to look inside subscriber traffic or mobile traffic and inside GTP tunnels and monitor that, and then figure out there's something bad going on that would cause an issue in the network, and apply appropriate filters that can, because of the silicon filtering, can look inside the payload and surgically block the packets we want to stop and allow all the good traffic to go through. So the situation you end up with here is now you've expanded the capacity of your mitigation beyond that fractional scrubbing capability. So it is in some ways an augmentation of what you might have installed historically, but you've taken it up to your provider edge, and this scales into terabit space. In fact, our largest license for this software is 40 terabits of protection. So what it's done is it's taken installed base of routing technology. In terms of what's available in the market and deployed today, Juniper is, I believe, about 12 months ahead of the competition. But you add some software that communicates with that deployed infrastructure and turns it into this DDoS detection and mitigation solution that can react within seconds and block this malicious traffic. So let's also share with you some observations about the move from 10 gig to 100 gigs in terms of internet transit. 100 gigs has been bubbling along for years. We've been working with it, testing it, seeing the interoperability issues, looking at the expensive optics and transceivers. But it's really turned the corner in late 2018, 2019. We've been following, if you follow the rule of thumb, if you want to be an expert on internet growth and cost of transit, you can use this 30% button, and that just generalizes or rounds up the bandwidth growth usage increase per year. So if you're a bandwidth user, a hoster, a provider, a customer, on average you're using about 30% more each year. Fortunately, at the same time, the cost of that transit has been going down about 30% a year as well. So the service providers need to sell you more transit to stay at the same revenue, or it's getting cheaper every year. But there's some other things kicking in now with 100 gig. And I talk to tier one providers, and they say, I'm selling more 100 gig than 10 gig now. And the next few bullet points help you understand why. So we all know demand growth for bandwidth continues. The technology costs are coming down, and that includes router ports, switch ports, also the amount of power that they consume, the density of that equipment, and the performance of the equipment, all moving in the right direction to support this. In terms of the fiber, the industry settled on volumes of this QSFP28 transceiver, which has helped dramatically. The long-range transceivers, which are the ones you're most likely to use for transit connects, have just been traveling nicely down the curve, getting cheaper and cheaper. A very interesting thing is that the fiber between you and your transit provider, your upstream provider, that single mode long range fiber, that same fiber that you have 10 gigs delivered on is also good for delivering 100 gigs. So there's an incentive for the provider to upgrade the port at the other end from 10 to 100, because he can deliver 10 times the amount of service over that same installed fiber. And that's why you can often buy 10 gigs or 20 gigs of transit over a 100 gig connection for the same price as buying two discrete 10 gig links. You're tapping into the economics of delivering 100 gigs over that fiber. And what we're seeing is that price race between the transit providers is in your favor if you're buying upstream transit. If you're not peering for free because you're a tier one or whatever, or in an exchange, you can really benefit from this. So that's going to drive a lot of people to move away from this picture at the top, with all the 10 gig links coming in all over the place. That was the last 5 years or 5 years ago. And it's going to be much more like this one, with one RU routers that can handle 400 gigs and require just a couple of connections. You can have two small routers, 200 gig links. You've got your diversity, your performance, your elastic expansion as you want more capacity, and you're off to the races. It does help as well with DDoS, because in this picture here I'm just showing a provider that has 100 gigs of connectivity over 10 links, and you'll see even with a 40 gig attack, some of those 10 gig links saturate and cause an impact on his network, and that ends up looking like this. So in that particular case, multiple 10 gig links here, a 40 gig, there was like a 45, 47 gig attack there. But some of the links, because DDoS is not fair, it doesn't come in evenly over all of your links from all of your different providers. It depends where the attacking resources are, which network they're on, or which network they're using as the shortest path to you. So they will saturate long before you've hit the aggregate capacity of your transit. That's much less likely to happen on 100 gig because you've got the linear bursting to the full capacity of the fiber. In this picture, you see some of the variability. This is one 20-minute attack, and you can see how its intensity spiked, 10x. This shows some of the challenge of deciding to feed that to the fractional scrubber when you're looking at one of the lower peaks, because in the next minute, it could be way above 10% of your edge capacity and saturating the scrubber. So let's take a bunch of those thoughts and look at some actual deployment topologies. So a very common one is the one at the top, which is optical inline. You put the 10 gig or 100 gig equipment in the fiber that comes from the transit provider. It's great because you don't have to change your configuration. You don't need any additional ports on your routers. There's a zero power bypass option, so you don't have to worry about power outages or service outages. And it's pretty much the lowest latency DDoS protection. It'll be negligible latency compared to the latency the packets are already incurring coming across the wide area internet. Another one is one-arm deployment, where you don't put it in series, but you actually just hang it off of the router using one port, and you can logically either always or on demand divert the traffic you want to inspect, mitigate up to the router. And just to give you some context of how easy this is becoming, I got the guys in the lab just to take a video of adding 100 gig protection to a link. So we've got 100 gig coming in from the transit provider, and the green box is a Corero DDoS mitigation solution. You unplug the 100 gig from the router, plug it into the DDoS box, take the jump fiber from the DDoS box into the router, and within about, I think it's like 25 seconds, that transparent device is now inline, and your network on that 100 gig link is protected from DDoS. Similarly, if you choose an alternate topology of one-armed, you take your DDoS mitigation equipment, you plug a 100 gig fiber in it, you plug that into one of the ports on the router, and then now you can logically divert the traffic to the mitigation equipment to put it virtually in line, as it were, with your network. That's just how simple some of these installations are when you go to install them at the rack or the colo or the remote office, wherever the transit is being delivered, with obviously the downstream wireless or landline network. There are other deployments supported too. It's pretty agnostic as to how you use it. It really depends on your economics. So just bringing it for completeness, the traditional scrubbing capability is available, so you can protect your subscribers and tenants by diverting traffic to this kind of detection, automatic detection and mitigation equipment. Or we also partner with tier one providers like GTT as a partner of ours. They've actually pre-installed a lot of that equipment you just saw inside their network, so you can just subscribe with a checkbox when you buy transit for them and say, I want my traffic to come through that protection before it's delivered to my location. So that can be useful if you have 10 locations you need to drop a 10 gig link into, or some 100 gig link or a 10 gig link or even 1 gig links. You can choose the option now to have your traffic come through, not some centralized scrubber that would require backhaul latency. These are distributed, sort of shortest path to your port, so the traffic is inspected. So let's try and wrap it up and bring it to some close here of the information we've reviewed. So commercial considerations might be interesting to review. You have lots of options. It's actually a good time to be considering DDoS protection or enhanced DDoS protection for your networks to maintain your SLA and your customer delight and happiness. You can outright buy the appliance. You can buy that green box or boxes like it from other vendors. You can buy that with or without the SOC service. You can, if you're big enough, you can do it on your own. If not, you can choose to have secure access to a managed SOC service for that equipment. you can actually buy the same equipment as a service, where you don't actually have to take title of the equipment, more like a set-top box. You can have the box in your network, remotely managed, and pay for it on a monthly recurring basis, just like you would do for your transit. You can get protected transit from providers like GTT, who have this kind of technology in their network already. And then when you purchase the transit and your aggregate CDR or number of ports, you check the box to have that protected with this DDoS detection and mitigation. Or you've always got the alternative to go to a third-party cloud redirect, where you would have to swing a whole /24 containing the victim traffic to a third-party cloud and then have it tunneled back to your location. There's nothing in any of these approaches that stops you doing that. In fact, devices like ours from Corero and other vendors have integrations that allow you to signal that redirection automatically. So your criteria when you're looking at this is, what's my transit going to cost? What's the incremental DDoS protection going to cost? Do I want to acquire it in CapEx model or a monthly recurring model? And do I want the managed service with it as well? Last slide, just running back down some of the technical considerations you'd want to understand. Real time, go for seconds rather than minutes. Otherwise, your protection is going to be useless for both the majority of attacks today and the direction those attacks are going in for the future. Automatic, otherwise your operator costs and the delays incurred by that won't provide you with a solution you like. Scalable, everybody's growing. You want to be able to take advantage of 10 gig to 100 gig and beyond 100 gig in the future. Low latency, increasingly important for 5G, IoT and edge compute. So go with something that's on your network and is effectively not measurable from the point of view of typically your public IP access. Analytics, alerting, visibility, reporting, audit. The tools that gave us the knowledge I've been sharing with you, make sure your product has an open, developing, well-supported ecosystem in that sense. True v4, v6. We invested in that, and we found it's been really important that our customers can mix and match v4, v6 traffic on any of this DDoS detection, mitigation, display reporting ability. Believe it or not, some products still lag in their v6 capabilities, or don't even have it for some of the inspection tools you need. I think you have to look at the payload to do a good job with DDoS. You can't just look at the header. That's just anomaly detection, not DDoS detection. The same for mitigation. You can't just block on the headers and expect low false positives. You have to be able to use the payload matching of silicon filtering to do good blocking. You want appliance and virtualized options. I happen to do pretty pictures of metal boxes. The same software, the same features are all available in VMs under KVM or VMware, so you don't have to use our Intel appliances. You can use your own compute resources if you have them. DevOps, SecOps friendly, that's the path to reliable, repeatable configuration for you. And then some degree of autonomic or machine learning friendliness in the product. There are going to be many, many more tools you can use in the future, in the coming years, that depend on the features that are extracted from the data by products like this and shared with those tools. So don't buy a product that's a dead end or blind in terms of these new developments. Make sure that you can tap into those benefits as you go forward. So with that, we've come to the end of the talk. Hopefully it's been interesting and useful for you. I'll make the slides available. We're always available at info@corero.com, or you'll find me on LinkedIn or the team on LinkedIn. We're here, we have a booth, and we'd love to share more of our experiences or understand any of your requirements or needs for DDoS protection of your networks as we go forward.